Recently, I have released videos explaining how to run dedicated game servers such as Palworld and Ark Survival Ascended on AWS or Amazon Web Services, and we used a tool called Terraform to do this. But I seem to have done a disservice to my community based on the amount of comments and questions I'm getting on what to do after my server is up and how do I manage it day 2. And so this video is going to go a little bit in depth on how we're going to manage our server after it's up, and how we can use Terraform to do that or not use Terraform to do that, how we can change settings, copy files back and forth between the server, and restart Palworld, patch Palworld, etc. Now before I get started, I just want to say when I made the initial videos, the goal was to get you up and running. It was not necessarily to teach you how or to become an expert in AWS or Terraform. These are tools that people get paid 6 figures to be really good at, and there are certifications that you can get for Terraform and AWS if that's a path you would like to go down. So when I made the videos, I was trying to give you the information you needed, but also not overload you with all the little details about how Terraform worked. And so that led me to not explaining how to make changes to the server. Before we get started, I did make some updates to the module since the last video. If you go over to the GitHub repo and you click on releases or changelog.md, you can see the changes as I'm releasing them. You can see the features and bug fixes. I did fix a bug where you would run a Terraform apply, your server would start, and everything would be great, but then when you ran another Terraform apply, it would remove port 22 from the security group. I've also added a new feature to allow you to use AWS SSM Session Manager for connecting and disabling SSH to make your server more secure. So what does that mean? What does SSM and Session Manager mean? Well, if we take a look at the examples and we go to the new example, SSM instead of SSH, we can set create SSH key false, enable SSH to false, which will not open port 22 on the security group, and then we set enable Session Manager to true. And then once your server is up, you can simply click on it, go over here to the top right and click on connect. And then you can go to the session manager tab and hit connect. And that will drop you directly into your server terminal from your web browser. Now that will put you in as the Snap SSM agent user. So you're going to want to do a sudo su ubuntu to switch to the Ubuntu user. And then you can navigate the server the same way you would if you were SSH'd in as the Ubuntu user. So before we get into the nitty-gritty of making changes using Terraform and what's involved in that and how a state file works, let's start with the simple things first. So whether you're using an AWS Systems Manager session like I am here, or you're using a Visual Studio Code terminal and you are SSH'd into the server, doesn't matter, same thing, follow along. Some of the most common questions have been, how do I update Palworld when there is a patch to get the latest version? And how do I make changes to my settings and then have them take effect in my world? So Palworld is running as a systemd service, and this is the equivalent of a Windows managed service running in the background. So if we run systemctl, which is the command to interact and start and stop and restart services, we can do status Palworld because that's the name of the Palworld service, and we can view if it's running or not. And then what we can also do is we can do systemctl stop, start, or restart Palworld. Obviously stop will stop the service, so the server will no longer run. Start will start it again, and restart will stop and start the service. Now, when you run any 3 of these, you also have to append the sudo command to the front of it, which is the equivalent of running it as admin on Windows. So if I run sudo systemctl stop Palworld and then systemctl status Palworld, right, I can see Palworld is inactive. It is no longer running. I can make my changes to my settings files, and then I can start it again with sudo systemctl start Palworld, and Palworld will start. Now, when you restart or start Palworld, Palworld will execute a script to download any updates from Steam. If we do a systemctl status palworld, this is the command that gets executed to start Palworld, but we have a exec start pre script here that uses the Steam CMD to run a script that will download and validate any updates for us. So every time we restart this service or stop and start it, Palworld will pick up an update. Now, a common question I get is, how do I update my server settings? Well, there's two ways we can do this. We can do it manually, where we go into the server, we edit the file, we restart Palworld, and that's that. Or we can modify it in state using Terraform. And I'll go over that in a minute. But first I want to go over the manual way, because some people just need to take the easy route, and that's okay. We're not here to tell you how to manage your infrastructure. So when you're in the server, I have Palworld set up to install in the palworld-server directory. So this is where all of our files are, our config files and our save files. So if we go into pal and we go into saved and we go into config, Linux server, these are our configuration files. Now we are mainly interested in palworld settings.ini. Now there's nothing stopping you from editing the rest of these files, but this is typically what people are asking me about when they're saying, how do I make changes to my server? So what we want to do is we want to use some kind of text editor to edit these files, or palworld settings.ini. Now, the one that I am used to is Vim.
I do not get why anyone would use spaces over tabs. I mean, why not just use Vim over Emacs?
I do use Vim over Emacs.
Oh, God help us.
Right? But I understand that that is not everybody's cup of tea. Some people prefer Nano, which I personally don't use a lot, so I don't know that much about it. But I use Vim, so whatever text editor you prefer to use, if you have to install one, you can do that as well. So using Vim, I will say sudo vi palworld settings.ini. And when I'm in here, because I know how Vim works, right? Every text editor is different. I'm simply going to use my arrow keys, or the N key to move to the end, or the home key to move to the beginning, to navigate through this file. And then when I decide when I'm in a place where I want to make a change, I'm going to hit the I key for insert. And maybe I want to update daytime speed rate. So I'm going to update that from 1 to 3. I'm going to hit escape. I'm going to type colon, WQ, exclamation mark, and hit enter. So now palworld settings.ini has been edited and it's been saved. So then once I've made the change to the file, all that's left is to, start Palworld if I've stopped it before I edited the file, or I can just do sudo systemctl restart Palworld, and then it will stop and start, and my new changes should be in effect. So that's how we change our Palworld settings manually. Now, how do we change them using Terraform? Well, that gets a little trickier, and we'll go over that now. So here I have my main.tf, similar to the way I showed you in the first video on how to deploy a server. And I'm calling a module. Now, in my case, I'm calling it from the local directory, and I'm providing inputs. So I'm using the module's examples directory vanilla palworld default settings. So this is my working directory, and we can see that I am in this directory. So I'm going to run a Terraform init. And a Terraform init is going to download our Terraform modules that we requested it to, and any Terraform providers that are required as well. And if we remember from the first video, a Terraform module is just Terraform code that someone else has already written and packaged up, and we're just consuming it and providing inputs. And a Terraform provider is just something we configure to tell Terraform what API to use and how to authenticate to it. In our case, we're using the AWS provider. So when that happens in your Terraform working directory, on the left-hand side here, you will see a .terraform folder got created. And Terraform will create a modules directory and a providers directory. And this is where it will store our providers and our modules. And then when we are actually ready to create this infrastructure, we run a Terraform apply. And then Terraform looks at our code. It says this is how things will be built, and you agree with that, and you deploy your infrastructure. Now you'll notice here on the left in my Terraform working directory, a file got created called terraform.tfstate. And this is what's known as a Terraform state file. And the Terraform state file is essentially the codified view of the current state of your infrastructure according to Terraform. Now, this doesn't necessarily have to hold true, right? If I run a Terraform apply and then I log into the AWS UI and I make a change, obviously the state no longer matches the real world. So then what happens every time I run a Terraform plan or a Terraform apply? Every time Terraform looks at the state file, and then it looks at the infrastructure in the real world, i.e. my Palworld server, and it says, are there changes or not? And we haven't made any changes, so there are no changes. But if I come into the AWS UI and I make a change manually, so say I go to my server and I change the name here from far over the Misty Mountains to test. Well, now the real world does not match the Terraform state file. So if I run a Terraform plan, Terraform is going to compare these two things. It's going to say, hey, I have a change to make. The name of the server is not what you have configured in code. I want to change it back. So then I'll run a Terraform apply. And you can see it says 0 to add, 1 to change, and 0 to destroy. And that's important, as we'll see in a minute. And then yes, I want to change it. And that changes my server name back to what I have configured in my code. And that's how a Terraform state file works. It's essentially a source of truth for how your infrastructure can be or should be configured. Now, there are some changes, like if I say create SSH key, if I change that from true to false, and I run a Terraform plan, well, now Terraform says, or it thinks, I don't want an SSH key anymore. So we're going to destroy the SSH key in order to bring the infrastructure into alignment with the state file. So I'm going to undo that real quick. So I say all of that because I want you to be aware of how the state file works in Terraform, because that is key to interpreting what happens to your server and your data when you're making changes. Now, I don't have an example of it to show you here, but some attributes, when you change them, they force what's called a recreation of a resource. So let's just pretend that if I had changed this instance type from T3 extra large to T2 extra large, and that was one of these recreate operations, when I ran a Terraform plan or apply, it would say 1 to destroy and 1 to create, because it's going to destroy the existing thing and recreate it. So just be aware of that. Always run your Terraform plans and always inspect them and be aware of the changes that you're making. And if there's ever a question, so say you did change a value such as instance type, and you run a Terraform apply, and you see that Terraform is saying 1 to change, right? We're going to change the instance type. If you are not sure if this is going to cause the server to be destroyed or not, in our case, we have to do a little bit of research to kind of figure this out. But I know that if I look at the source code, if I follow the breadcrumbs through the Terraform module that I'm using, right? I go to modules, compute, main.tf. Instance type is defined in the AWS instance resource. So then I could come to the HashiCorp registry documentation, go to the browse providers, AWS provider, documentation, and I'm looking for AWS instance. Under the EC2 section, if I click on it, this resource, I can see all of the attributes that are applicable to this resource. So with all that out of the way, what does this have to do with changing my Palworld settings? These Palworld settings are actually dynamically interpolated into a template. So what does that mean? It means what I am doing in the Terraform module is I am creating a user data script, and I'm taking your inputs and I am passing them into the user data script. And a user data script in Amazon EC2 terms is a script we provide when we first create a server that gets run during the first initialization of that server. So if you actually come over to your server after it's created and you go to the top right, there's an actions button. You can go to instance settings and you can go to edit user data. And this will actually show you the user data script that got built and run the first time your server started. And why that matters is because let's say I change one of these settings that is actually being passed into the user data script. So exp rate, I'll change it to 3. And then I'll run a Terraform apply. And we'll see 1 to change, right? We're changing the user data. Now, none of this makes sense because it's base64 encoded, but we're not actually changing the server. We're changing the user data that is attached to the server that gets run the first time the server gets created. And why that matters is because even though we update this, the server is never going to be created for the first time again. It's just not. And there's no way for Terraform to go into the server and modify the existing files based on our inputs here. Now you'll see your server restarting when you update user data, but the user data will not actually take effect. So with my server back up now, after I've made that apply, I'll go into Palworld server, pal, saved, config, Linux, and we're looking for exp rate. So cat Palworld settings, grep xp. Is it caps? Yeah. Exp rate. Right, we see it's still at 1 because user data was not applied. Now there is an attribute which I have not included in my code, user data replaced on change. If I had set this to true, then every time you updated user data, it would destroy the server and recreate it with the new inputs. But you would lose your data, your pal. Have I been saying Minecraft? If I have, I apologize. Your Palworld data would just be gone unless you were backing it up. Now, I will probably add this as a feature and allow you to set it true or false yourself and just default it to false to protect you from yourselves. So if I really wanted this change to take effect, right, I wanted my server to start with the exp rate set to 3, I would have to do a Terraform destroy to destroy the instance and everything around it. Or I could do a targeted destroy if that's really something I want to do. I'm not going to go over that in this video. You can target one specific resource, so you could just destroy the instance, but keep everything else around. And then after it's gone, you can rerun a Terraform apply, and then the server would be started with this new value here. Optionally, you could go into the UI, and you could just click on your server, instance state, and terminate it, and that would destroy it. And then once that has been terminated, you can come back to Terraform. You can run a Terraform apply. Terraform looks at the real world, sees that there is no server, but according to your state file, there should be a server. And then so you'll hit yes. It'll recreate the server. The server will use the updated user data script with the new value, and that will be what takes effect. And at that point, you just have to figure out how to get your backups back onto the server. One of the other common questions I get are, how do I push a file from my PC to the server, and how do I get a file from the server onto my PC? And the easiest way to do that would be with the SCP utility, which is included in most Windows and Linux distributions. Now, on Windows, you can also download WinSCP, which is a graphic UI tool for performing this. But we're going to use the command line utility SCP. And we're going to start by passing in -i and then the path to our SSH private key. So mine would be Palworld public key. And then next we're going to do the file on our local PC that we want to copy over. And so I have a folder here on the left called assets, and I've got some player data and world data. And so I want to move the level.save file. So 2 directories down relative to where I'm at currently in this directory is the assets folder, level.save. So that's the file I want to move to my server. So I'm going to then provide the user that I want to connect as, which would be Ubuntu, and then the IP address of the server. Next, I have to do colon, and then the path on the server, the remote server, that I would like to dump my file. And I'm going to put it in the home Ubuntu directory. And if all goes well, you'll just see the name of the file. That's it. So now I'm going to SSH-I, 2 directories down, Palworld public key, Ubuntu at the server name to SSH into the server. And I'm in Ubuntu's home directory right now. And I see level.save. So I successfully pushed a file from my PC to the server. Now let's say there's a file on the server that I want to get back to my PC. So we'll go to Palworld-server, and if we look at everything in here, it's actually owned by the Steam user, not Ubuntu. So the first thing we have to do is, let's just by example say I want save games 0, whatever that is, and then I want level meta.save, right? I'm gonna have to first copy level meta.save to home Ubuntu, and change the owner to Ubuntu. Would help if I could spell, right? Okay, so now I've got level meta.save here in Ubuntu's home directory, and it's owned by Ubuntu. So I'm going to exit the server, go back to my Windows PC, and we're going to run the SCP command again, SCP-I, path to the key to connect to the server. But instead of providing a file on our local PC that we want to copy to the remote PC, after the key, we're just going to provide the name of the server, or the name of the user on the server to connect to, which would be Ubuntu, the IP address, the colon, and then the path to the file. So level meta.save, and then the path on our local PC where we want to put this file. So you could say like C drive, desktop, whatever you wanted to. I'm going to say dot or period, and that specifies the current directory I'm in. So I'm going to run that, and if all successful, again, you'll just see the name of the file appear. But now you can see on the left here, in my vanilla Palworld default settings directory, level meta.save has appeared. I successfully pulled it down from my server. And so that's how we can manually move files back and forth very easily between the server and our PC. Now there's other ways to do this. You could use like the AWS CLI to push the file up to an S3 bucket that you create, but that's beyond the scope of this video. Now I do have examples on how to enable backups and restore from backups, right? So if you look at the example on backups enabled, if you provide these inputs, Terraform will create an S3 bucket. So what's an S3 bucket? If you go into the services search bar and you search for S3, an S3 bucket is just a place where files can be dumped and then pulled from. And then you can define how long you want backups to stay in the S3 bucket. if you want the bucket to be able to be destroyed while there are backups in it or not, and then how often should the Palworld server copy backups to the bucket using a cron expression. And I put a link here to the cron expression calculator if you're not familiar with that. And then there's another example, restore from backup. So if you have files, right? So maybe you had enabled backups and that was putting backups in the S3 bucket. And so you download those to your local computer, you destroy the server, and then you want to upload those, right? Well, these are the relevant inputs related to that. So you can have your backup files on your local system, but you have to have them as I have them laid out here. So you have to have them all in one folder. You have to have a folder called players with the player data, and you have to have it structured just like this, or it's not going to work. Or you can have optionally an S3 bucket with the files in the correct structure. And I point that out here. Same structure, you have to have a players folder with the player data, and this has to be structured like this. But in both cases, you would say start from backup, where the backup files local or S3. And you need your old servers. Some people are calling this a group ID, GUID, object ID. I'm calling it a hash. Who cares? Point is, you need, if you go into game user settings.ini on your server, you need the dedicated server name value of the old server because that has to match with the data that you're restoring from. And then obviously if you're restoring from local, where on your local PC relative to the Terraform working directory. And if you're restoring from S3, you already have a bucket somewhere. What's the ARN and the name of the bucket?